Hi, welcome to my channel, JaberTime, where I do math videos from algebra to calculus and differential equations, simplified with examples. Today I'm going to go over histograms and stem and leaf plots, as you could see on the first slide. Next time I'll go over bar graphs and dot plots, all right? I'll try not to make them all in one video because I don't want the videos to go over and get close to half an hour. If I could make them around 10 minutes, less or more, that should be, I think, fine. Let's get into it. A histogram is similar to a dot plot, except that each bar represents data in an interval numbers. Dot plots, they go like number 15 how many, number 16 how many, and you just keep making dots. Histograms, they have intervals, as you could see. There is none between 60 and 75, and the story continues. Now, one thing I want to let you pay attention to. In histograms, we deal with x-axis as intervals attached, as you can see, and frequency on the y-axis. But make sure that when you start building the histogram, you look at the numbers and you count for each interval how many. In case you are dealing with the second bar, 15 to 30, you want to make sure that 15 belongs to you, 30 does not belong to you. 30 belongs to the third interval. This is something that you want to keep in mind, all right? It's mentioned right here, but I want to try there, as you can see. I want to move on and be practical with you and save you some time. If you want to read this and you feel like I'm going a little bit fast and I'm not reading it, you could pause the video by hitting the spacebar. You could hit the spacebar again to play it. So the spacebar plays as a remote control, pause and play. If you want to move forward, you hit the arrow key, the right arrow key. Every time you click on it, it moves a few frames. If you want to go back, you click on the left arrow key. Keep that in mind. This is what I meant about the second interval. From 15 to 30, not including 30, we have 10, as mentioned right here. Let's look at what is the difference between bar graphs and histograms. Histograms, they go as attached, the one that we saw. Bar graphs are usually not attached. Not only that, histograms, they go intervals. Bar graphs, they go with titles like sports, colors, and so on. Dot plot are pretty much, they go with frequency and with numeric data. This goes with categories. Let's take a look. That's more in detail, but I want to add to it and make it more clear as a slide. This histograms and dot plots refers to numeric data. Order matters, as you could see. We were looking at histograms, and we were looking at intervals from 0 to 15, from 15 to 30. So yeah, order matters. Dot plot, if you remember, we talked once about how many bits do you have, and on the number line you go like 0, 1, 2, 3, 4, 5, and if you have, let's say, 17 students, they say like we don't have any bits, that's going to be on top of the 0. You just stack 17 dots and so on. If you have, let's say, 3 students, they say like we have 2 bits, you just go on top of the number 2 and you make 3 dots. I think that's clear. Let's go to the bar graphs. They are categories, titles like sports and colors. Order usually or generally does not matter. Okay, let's move on. Stem and leaf are like histograms. Why is that? There's too many ways to support that. They go with numeric data and they go with frequency. There is more into this paragraph, but I want to skip. I'll leave it up to you to read if you want to stop the video and read it. But as a histogram, it says that we are dealing with numeric data. Stem and leaf deals with individual numbers, where histograms deals with intervals. So it kind of like groups them into intervals. Stem and leaf tells you exactly how many 52s you have. Histograms, it tells you that 52 belongs to an interval, or the interval of 50s, if you go from 50 to 60, you cannot tell how many. 52s you have. Okay, so just slight differences, but they're about the same. Here's a stem and leaf. It's already done for us to save us some time. We make a vertical line, 4 to the left, 9 to the right. That's 4 and 9. To read this clearly, look at this right here. Those are called stems and those are called leaves. 8/2 space 3 reads as 82 and 83. All right, I think that's good enough for this. To discuss the following data in stem and leaf, it's already done for us here, and they want to go over and make some comments about what's happening with this. Well, first of all, I think it's a clear notice that there is no 50s. If somebody goes 3 and 4 and jumps to 6 and 7 and does not include the 5, I think it's misleading, because you're telling the audience or the viewers that don't look at the 50s. I don't have any 50s. Well, I think if you do it this way, you're actually telling them clearly that you don't have any 50s. So you want to include the 5 to show everybody that there is no 50s, all right? Think about how this plot arranged and describe what you notice. Think about the 42. If you want to put it in, if it comes in, how do you do it? Well, you move the 3 and the 7 to the right, you put 2 here, then the 3 will be here, and the 7 will be here. What about 102? Well, 102 is down here. You need to show the viewers that there is no 80s and 90s. Then you write 10 on the left and 2 on the right. That's how you do it. All right? We already talked about why 5 is blank, and I think that should do it. As I said, if you want to read this, you could pause the video and read it, but we just went over it to be more practical. Okay, let's move on. I have this right here, and they want me to practice to build a stem and leaf. They gave me the start, 1, 2, 1, 7, like 12 and 17. Here's 12 and here's 17. Looking at these numbers, that's not the best way to look at numbers and see like what's a max and what's a min. But if you see it organized in stem and leaf, you could tell. I think the minimum is 12. I think the maximum is 92. And I think if I move this 90-degree counterclockwise, I could see it almost like a histogram or a bar graph or dot plot. And I could tell that it's more uniform. That means it's not centered in the middle with higher frequency in the middle. It's almost like a rectangle when you do it. So I think you got my idea. Trying to keep it under 10 minutes, guys. I have just a few slides left and we'll close and end up this video. This is data that you want to make a histogram, as you can see right here. That's not too hard. 0 to 3, you want to count how many, and you want to raise the bar. So let's take a look. How many lives between 0 and 3, but not including 3? Just keep this in mind. 2 belongs to it. 3 does not belong. 3 belongs to the second interval. So we're going to take 2 here. Any more? Less than 3? No, just 1. Let's move on. Yes, only 1. You could double check, as you could see, and hit the space bar and make sure that everything belongs to the right bar. 3's all the way less than 6 belongs here. So this 3 counts on the second interval. This 6 counts on the third interval, and so on. All right. Here's another example. Use the data to create a dot plot. Why is the dot plot not the best choice? Well, I could see that the dot plot is not a good choice. To me, it's so clear. The numbers are all over the place. I don't see enough frequency. When you deal with number of bits, the number of bits will be either 0 or 1 or 2 or 3 or 4 or 5 or other. So people will raise their hand for number of bits as 2. This is how you stack the dots and call a dot plot. Here, I mean, if I look at 32, just for example, how many 32s do you have? So far, I don't see any. So how can I make a dot plot? On top of 32, I'm just going to make one dot and move on. So it's not going to be practical. For this one here, there are too many different values. It's not an idea about frequency. So that should do it. Use the data below to create a dot plot. Students should notice that a dot plot is difficult. That's why here on part B says, it's not good. You experiment with it, you go like, oh, I make a lengthy number line, but there's not enough frequencies. So part B is supporting part A. Create a stem and leaf, create a histogram, and discuss the histogram and the stem and leaf. Let me show you the graphs and we'll stop the video right there. This is the histogram and this is the dot plot. They are so similar in many ways. If you move this counterclockwise 90 degree, it's almost gonna look like this. Look, this is a 3 in it. This is a 3, same height. Look, 3, 3. This is the shortest at the end, shortest at the end. The difference between them is this one exactly tells you that you have 25 and 28 and 29. In the 20s, here it doesn't tell me. It tells me there is 3 numbers in the 20s, but it doesn't tell me what are they. How many 25s do you have? Well, this one does not tell me. This one tells me. Okay, that's one benefit on the stem and leaf compared to the histogram. But as you can see, it's another point view. Hopefully that was clear, not too lengthy. It's about 12 minutes, 13 minutes. And I'm going a little bit fast because I don't want to make it half an hour. And I'll thank you for watching, and I'll see you in the next one. Thank you.